we are with a 2011 JK on a relatively warm day. Ironically, this Jeep's not overheating. I got the AC on right now, but you can see that winch is causing a significant amount of airflow to be diverted away from the grill. Looks like we got coilovers, anti-rocks. Pretty sure, yeah, this Jeep's got an oil cooler. I don't know if you can see it. Bead locks, 1-ton brakes, PSC, Motec battery tray. Look at that, he's got a fan on his hood. I'm guessing that might have been from before. He was having overheating problems. Ironically, I'm not having any right now. So a typical LT1 setup, guys. It might be an L86, I'm not really sure. This morning we're in a, well, I'm gonna call it a mid-year JK because from 2007 to 10, Jeep ran the 3.8 liter engine with the old interior. In 2011, they ran the 3.8 liter engine with the new interior. Then in 12, of course, they installed the Pentastar with a new interior. So I consider that a late JK and this a mid-year JK. The 11 is very similar to the 12 inside the vehicle, but very different under the hood. This Jeep is lifted, it's got 42s or 3s, got all sorts of stuff, 1-tons and sway bars and you name it. I thought this might be a good time to talk about drive lines because I get a lot of questions. What do I need? What axle do I need? What drive shaft do I need? Do I have to beef this up or that up? If you have a relatively stock JK, maybe you're on 33 or 35-inch tires, you don't have armor and a 6-inch lift and skid plates and all that stuff. So it's a relatively light Jeep on 33s to 35s. In most cases, you can run stock axles. You don't need to upgrade. Now, I do recommend that you upgrade the drive shafts for 2 reasons. One is you want to custom fit them. In most of our conversions, we do move the transfer case back anywhere from 1/2 inch to 1.5 inches. On the 6L90s, maybe a little bit more than that. Drive shafts do have some flexibility if they have a lot of spline, but then the other part of that is your suspension. If you have like Metal Cloak or Synergy and one of the good suspension brands, they know that when you lift a JK, the axles move inward. But what a lot of suspension manufacturers do is they just make the control arms longer, and that way they push the axles back out where they need to be. And better yet, you want to get adjustable control arms. So if you have a Jeep with stock suspension and you haven't done a lot of lift to it and you have adjustable control arms, there's a chance you can use your stock shafts, your RZEPAs. Now, I really wouldn't recommend that. I had a 2008 JK with a 5.3 LS. It's going on 300,000 miles and it has a stock RZEPA shafts in it. But that Jeep was never really abused. It is pretty much on the ground. It doesn't have that much of a lift. It has a budget boost. But once you start going 3-4 inches, and if you get the larger engine, anything over a 6-liter LS, I do recommend that you upgrade the drive lines. Get the conversion done. Get the vehicle on the ground with all the weight on it. Then measure flange to flange for your drive shafts. We use Adams Driveline Service out here in Vegas. I've known those guys for decades. They use good parts, American Spicer. They don't try to cheap out and use Chinese stuff. Just a few years ago, we were paying just about $1,000 for a set of shafts. That would be for a 1350 rear CV with a 1350 flange, and then a 1310 CV in the front with a 1350 flange. And you ask, why do we do that? The reason is that the CV is right next to the transmission pan, and when the front axle stuffs up, it pushes that CV into the transmission pan. And even on stock JKs, you'll see the rubber boot tearing on the RZEPA because it's hitting that transmission pan. So we run a slightly smaller diameter front CV, and the 1310 is plenty strong for most builds. Now, can you run a 1350? Yeah, you probably can. You might have to change a few things up, but if you absolutely have to have it, you can. We even run 1410s in some applications like the supercharged Jeeps. So those shafts today, I think, are pushing $1,400 rather than $1,000. But like everything else, you can't buy a dozen eggs today that aren't more expensive than they were a few years ago. Now, axles are probably the big one. Do you need them? What do I need? Rubicons come with 44s front and rear, and then most of the other JKs come with a 44 in the rear and a 30 in the front. Rubicons also come with lockers, electric lockers, e-lockers, and they are an option on non-Rubicon Jeeps. I think some Saharas and maybe even Sports, I'm not sure, you can order the rear E-locker as an option. But in any case, I find that the 44s are plenty strong for the guy that drives normal. He doesn't push it. If you get into a tough spot, you don't just floor it to get out of it. You ease the throttle on and get out of it. Because remember, even with the V6, you can break these axles if you drive like a gorilla. I had a guy in Moab, this is quite a ways back, maybe 7 years ago. He had an LS3, and he had dropped his front left tire into a couple of rocks. It was wedged into a couple of rocks, and rather than just ease out of that, he gave it throttle, and it snapped the C right off the axle. So you got to drive reasonable. If you're going to go out there and you're going to hammer on it, then by all means upgrade your axles. I have a 2009 JK. It's got 100,000 miles on it now with a 6.2 LS. I've got stock 44s in that Jeep, and they're still perfect. They don't make any noise. That Jeep was driven by the press way back in 2010 and somewhat abused, but I'm running 35-inch tires, and essentially 35-inch tires will act as a safety valve. When you get 40-inch tires and they hook up, that's when you start breaking stuff. Now remember, GM powertrains do have axle protection modes, so it limits how much torque can be put out and when, like off the line. If you had 40s, it was a hot day and they were sticky, and you launched with stock axles with an LT1, you're probably going to break something. But if you got 35s, you got torque management active, and remember, you're also fighting the Jeep system, because the active braking in the Jeep will also try to keep the wheels from spinning. So for the most part, if you've got a relatively stock Jeep on 33 to 35-inch tires, you don't drive aggressively, the stock axles should work. When it comes to beefing up axles, you've got several choices. You can take the 44s and beef them up. You can put hardened shafts in, you can gusset the C's and sleeve it. In fact, there's a lot of shops that do that, and I've had many customers happy with that. It's a lot less costly than a new set of axles, because a new set of axles is really expensive. But the reality is, at some point, you're going to have to beef those axles up. If you're going to drive like a maniac, if you got larger tires, and I keep saying larger tires because the difference in magnitude between the weight and the momentum of a 32-inch stock tire and a 40 or 42-inch tire, I think I'm driving a 42 or 3 right now, is massive. These tire wheel combos can weigh over 200 pounds each, and you multiply that by 4, and you could be pushing 1,000 pounds of wheels and tires, and that's a lot of stress on the drivetrain. Like I said earlier, the smaller tires also seem to act as safety valves. I've had Jeeps on 35s where we smoke the tires, and that's fun, but then you put 37s or 40s on there and they hook up, and bang, that's when you start breaking stuff. I remember a build we did with a customer in Michigan a few years ago. He did it wasn't an LT4, it was the LSA, the old LS supercharged engine. He ended up breaking a Dana 60, a Dana 70, an Atlas 4. He just broke all sorts of stuff with that because he was trying to get a 0 to 60 time. And he did. He got some really incredible 0 to 60 times. He went through a lot of parts. The reality is, if he drove that Jeep normal and wasn't launching like that, he probably never would have broke it. So you could beef up the stock axles, but if you're going to be going to 38s or 40s, you might as well just go to 1 tons. I would say 60s are a good option. You can build them almost any way you want these days. 8 lug, 6 lug, you can get E-lockers and air lockers, whatever you want. You can get any joints up front, you can get RCVs. I do recommend, if you do get aftermarket axles, try to get unlocking hubs. Unlocking hubs, in my opinion, can get you better economy, better drivability. By not making that front axle spin all the time, winding the drive shaft up, which winds up the transfer case and turns, you get better economy. You might see that the steering is slightly better and freer. Jeep did a lot of studies. Now you'll notice on the JL that Jeep went halfway back to the unlocking hubs by adding that axle disconnect on the front axle. It used to be vacuum operated on the older vehicles. What was it, the TJ or the YJ? Now it's electric and it's controlled by the computer, of course. But what that does is, by separating the shafts, you're reducing a lot of friction, but it's still not as good as hubs. And I remember seeing studies on the JK. They did determine that the JK would lose a little bit of drivability and economy, but it was very, very low, just a few %. And the cost of not putting the hubs in, or the savings, was dramatic to Jeep, hundreds of dollars. And that's a lot of money when you're making hundreds of thousands of vehicles. So that was one disappointment with the JK for me, was the fact that it didn't have unlocking hubs. Even my old Toyota pickup truck has unlocking hubs with the old Bilford joints, and I can actually tell a difference when they're locked up and when they're not. If possible, get unlocking hubs. 60s are going to do it for most of you guys. You know, the average guy that's a weekend warrior, he goes out on the trails, he's got 37-inch tires. He may not drive like a maniac, but he does drive a little aggressive here and there. 60s should be fine for you. Pick your manufacturer. There's so many of them out there. But I will warn you, some manufacturers do a better job on the bracketry than others. Like, I like to see track bar mounts that are in phase with the drag link, and we've had a lot of issues with that lately, where they just set the brackets up wrong and you get bump steer and torque steer, or the shock brackets are sticking down too low. If you got coilovers versus shocks, that's gonna set the brackets up differently. So there's just a lot of variables. Talk to a knowledgeable four-wheel drive shop and get the axles that work best for you. If we step it up a notch for those guys that have supercharged engines, or they got an LT1, don't fool yourself. The LT1's got a lot of power. So does a Hemi. So does a 6.2 LS. And you're just gonna go out and beat on it with 42s, whatever. You gotta get the strongest axle you can get. Guys like the 14 volts, the Dana 80s, even the Dana 70s. Pick your preference, but you're gonna want a heavy duty axle. And there's some limitations to the heavier duty axles, like what lockers you can get, flanges for drive shafts, bolt patterns, etc. So do your diligence on that. They got a lot of guys that buy these heavy duty axles, they put them in, and oh man, now I got to change my tires, and what do I do with the brakes? And let's talk about the brakes a second. If you have larger tires, you probably should step up your braking. For the longest time, there were companies just taking 3/4 and 1 ton truck brakes off of Ram trucks or whatever and fitting them onto the JK. And there's not a whole lot wrong with that, but it has to be matched to the master cylinder. I remember after the JK came out and these big brake kits came out, they're running these massive 4-piston calipers with a stock master cylinder. And the pedal would virtually sink to the floor. You would stop and you'd call the manufacturer and say, hey, you know, my Jeep stopped, but the pedal feels really soft and soggy. Oh, that's how it's supposed to be. You got a lot more volume in the caliper now with a small master. Then some higher volume masters came out. I was never really happy with the quality of the aftermarket masters, but the JK8 master finally did come out. The JK8 booster and master, and that kind of solved the problem. It still may not be an OE feel, but it's close. There is another option that I really like, you may consider, that's less costly than the full big brake kit, and that is the caliper relocation kit. I think it was a company out in California many years ago that started offering it, and they had these really beautiful machined billet brackets and vented rotors and all that, but it was expensive. And sure enough, the capitalist economy, a bunch of companies came around and basically copied it, but made it out of forged steel instead of billet aluminum, and gave you the option of cheaper rotors. So now you can pick them up pretty cheap. I think you can pick up an axle set for about 300 bucks. And what they do is they take your stock JK calipers and they move them out further so you can run a larger rotor. By running a larger rotor, it means you have more leverage. You can grab the outside of the rotor and it will stop your vehicle more efficiently than if you have a small rotor. And I've been running those for years and I really like them. I think for something in the middle, like you have a JK that's a little bit pimped out, you're not too hard on it, you got 35s, maybe 37s, those caliper relocation kits work really good. So relatively stock Jeep, stock axles should be fine. Mildly modified Jeep, step up to about a Dana 60. Highly modified Jeep, or you drive like a maniac, go to a Dana 70 or 80, 14 bolt. Fusion has some really nice options out there. You can pick your medicine. Now let's talk about the transfer case for a second, because many guys call me and say, hey, do I want an Atlas? And I say, I don't know, do you need an Atlas? And they don't even know what an Atlas does. The Atlas is kind of a copy of the older twin stick transfer cases like the old Borg Warners. And what it allows you to do is it allows you to run each axle front and rear independently. As you know, with the stock JK 241, you have two high, so only the rear axle is driving. But don't fool yourself, that front drive shaft is also driving. It's being driven through the tires because there is no unlocking hubs. The wheels rotate, they're spinning up the ring and pinion, which is then spinning up the axle. So the disconnect is inside the transfer case. Now in a chain-driven transfer case like the 241, it's really not a problem because chains are low friction, you're running a really low viscosity ATF, and they don't build tremendous heat up. Now you get an Atlas with a counter shaft and all those gears in there spinning around, You have heavyweight gear oil. You got a skid plate on your Jeep. It's summertime and it's 110 out. You go down the highway at 80 miles an hour going around the sweeping turns. It's spinning up that transfer case like a whirling dervish, and it's building tremendous heat up. I've seen them hit 300 degrees. I've seen the seals melt out, the oil then comes out, and bang, you lock the thing up. Now, that was years ago. I actually spent time with Mike and Steve at Advance, and they kind of did a redesign on the Atlas. I don't know if you remember, a few years ago, they made some changes. As far as I know, they're not offering the oil pump that they were showing off at SEMA. Maybe they are, but most Atlases don't have them. The 241 does have an oil pump, so that's another benefit of the 241 over the Atlas. But they kind of did a redesign, and I don't want to get into all the specifics, but they took a JK and they cut the floor out, and they used thermal probes and look at the temperatures, and the bottom line is the Atlases now are very reliable. If you have unlocking hubs, like I've said many times, and you unlock the front axle, you have no more problem, because that front drive shaft is no longer spinning up the transfer case when you go around turns. The transfer case has also been known as a center differential, and that's for a reason. If you've got the front drive shaft and the rear drive shaft solidly locked to an axle and spinning, something has to give when you go around a turn, and that is the transfer case. So what are the benefits of the Atlas? Well, there's a lot. One, it's stronger, and you can pretty much buy any amount of strength that you want. They have the race case, they have these hardened pins, they have all this stuff, larger pins. I don't know the specifics of it, but when I call over there and I talk to Steve, I say, hey, I got 800 horsepower in this LT5. Build whatever you need to build, and he'll do it. Now, the prices of Atlases, again, have gone up significantly, just like everything else. So buy what you need. You probably don't need the top of the line race case good for 1,000 horsepower. But if you're running an LT1 and you got 38s and you go out to the trails at Moab or Logandale or Sand Hollow, get the Atlas that'll work for you. And I think the standard Atlas is plenty strong for that. We've seen very, very few failures. In fact, I think the only failures we've really seen were heat related, where they overheated because guys had full skid plates in the summer and they were driving hard and overheated them, and then they developed oil leaks. The biggest advantage of the Atlas is obviously going to be the modes that it gives you. With a JK, you have two-wheel drive high, which only the rear drive shaft turns, or is being driven, let's say that. Then you have four-wheel drive high, where both drive shafts are being spun up. Then you have neutral, which is pretty obvious, and then you have four-wheel drive low. That's all you got. When you're in four-wheel drive high or low, the axles are locked together through the transfer case. Now, there's certain maneuvers, and I will never experience this, but some of the real hardcore off-road guys do prefer to go into front digs where the front axle's just driving, or if they're climbing a rock, they got a lot of traction, they don't want to risk flipping over, so they just want to engage the front axle. Or like me, when I go up some of these switchback trails, like up here on the back side of Red Rock, we got a lot of trails that go to the top of these mountains, and you're just turning left and right constantly. And I want to release that front axle. I got plenty of traction, and I don't need four-wheel drive to go up these trails. So what I want is low range. I'm going slow, I'm going up steep trails, but I want good steering. So what I can do is I can engage the rear axle in two-wheel drive low, and then release the front axle. So essentially what the Atlas does with the twin stick, it allows you to go into high or low in the front axle, or neutral, where it's not doing anything, or high or low in the rear axle, or neutral, where it's not doing anything, and anything in between. So that means you can pretty much pick any drive that you want for the situation. Obviously, Jeep had cost in mind when they built the JK, so just offering those modes was fine. I want to go sideways here a little and talk to you guys about something Jeep built into the JK that many of you may not know about, and it's called brake locking differentials, or BLD. It's part of the ESP, or the Electronic Stability Program. And what it does is, when you're going up a hill or mud or snow or whatever, and you start losing traction, it does what a Land Rover does. Or, like we did back in the 1970s, by pulling the e-brake, we would transfer the power from one wheel to the other. Because with an open differential, essentially the wheel that has the least amount of traction is the one that's going to turn. So by applying an e-brake, we kind of neutralize that, and we can get some traction over to the other side. Well, with modern electronics, we can step that up quite a bit. So this actually happened to me at the Pioneer Saloon. There's a pretty steep hill out in front, and I always get challenged to climb it. I wanted to climb it with my 2008 JK. It had a Dana 30 in the front, Dana 44 in the rear, 32-inch tires, no locker, and as expected, one of the tires started to spin. or actually two, because you got one in the front, one in the rear. But by applying a little bit of throttle, not a lot, if you just floor it, you know, you're going to dig a hole. By applying a little bit of throttle and waiting a few seconds, you could feel the braking, the active braking come in on those spinning wheels. And then it would transfer the power over to the other side. And then of course I got up the hill. Now I've done this many a times, and Jeep has changed the programming over the years. Some guys say it doesn't work in four-wheel drive low. I do think it works in four-wheel drive low. It's one of the few aspects of ESP that isn't canceled in four-wheel drive low. So even if you don't have a locker, the brake locking differentials can help you out. Now while we're talking about lockers, what's the best locker? Well, again, it just depends on what you need. In my opinion, the best locker is a selectable locker. What that means is you have full control. You can have an open differential or a fully locked differential. Nothing in between, open or locked. That's how Rubicons are. They use an electronic locker. When you lock both axles in a Rubicon and then you put the transfer case in four-wheel drive, that's as much traction as you're gonna get. You're not gonna get any more traction by going to an Atlas. BLD is not gonna help you in that situation. You're locking all four wheels together. And actually that's what I prefer, because when you go between an open differential and a locked differential, and there's many choices, they call them automatic lockers. There's Detroits and Torsons, and the old hot rodders might remember the Posies, the Positractions, which use clutches. There's been a lot of different ways to get traction on both sides of an axle when you're not running a selectable locker. And by selectable meaning, whether it's a computer or you can turn on and off and lock that axle. There's also things like aux lockers, which are cable lockers, but essentially it's the same thing, it's just mechanical. On the old Toyotas, there was an electric motor that hung out the side of the differential. However you do it, a selectable locker means that you can control it from being open or locked. With an automatic locker, not so much. If you look at the Torsen, it uses gears to create friction that then transfers the power to the other side. The most common, I think, automatic lockers would be the Aussie locker type, and there's many different versions of it. But essentially there's a center pin and these two cog cam plates that when one side starts spinning, it separates these cogged plates. That cam action creates more friction and transfers it to the other side. And they can be a huge benefit off-road. They really are. I have a friend with an XJ, and he was getting stuck all over the place until he got some Aussie lockers, and now he's doing much better. Now, the downside to the automatic locker is they can be annoying. If you have the Aussie locker style with the plates or the cogged deals, they'll click. When you go around a turn, you'll hear a click, click, click. That's the Aussie locker engaging and releasing, and you've exceeded the torque that is required to keep that locker locked. So when you're going around turns, especially in the highway, it can be really annoying. You might even get some steering wheel input as the thing clicks. The Detroit lockers and others are probably less annoying, but the bottom line is an automatic locker is going to probably cost you less than a selectable locker, but it's not going to be as functional, and you're going to lose a little bit of drivability. I'm a big fan of e-lockers. I just like the convenience of not having an air compressor and air lines, and in freezing temperatures and moisture and solenoids and all that. I just rather not have to deal with that. Now, the air lockers like the ARBs do have advantages. One is when you turn that switch on, essentially it's locked. It doesn't take very long for that air locker to lock. With an electric locker, you engage it, and then there's this spring-loaded plunger that, until everything lines up, it's kind of like a synchro in a transmission, you're still going to be in two-wheel drive. And then as you drive the vehicle, and you want to kind of drive straight, maybe rock the wheel just a little bit, the steering wheel, to release pressure, the electric locker will lock in, and then it stays locked until you unlock it. I remember an old, I think it was a Nissan commercial, when they went with their automatic locking hubs. You put it in four-wheel drive, and you had to drive like 15 feet before the axle would lock. Well, the problem is if you are stuck on a hill or in a rut, you don't want to have to spin the tire to get the locker to lock. You'd rather just flip a switch, bam, the air locker's locked, and you go. The e-locker doesn't have quite that functionality. If you're doing a steep hill climb or even a descent, for the most part, the e-locker will stay engaged until it is given a command to unlock. So if you're going up this hill and you rip the wires out, a fuse blows, whatever, you're going to stay in four-wheel drive, which is what you want. With an air locker, if you lose air pressure, you are unlocked. So if you rip an airline off, you're unlocked. I've seen guys out in the desert with full skids, and I keep saying full skids because I see so many problems with them. That space between the floorboard and the full skid is like an oven in there, and it melts wires. I've seen compressor wires catch on fire. But I've seen the plastic blue ARB locker lines just melt. And when they melt, you lose your locker. So I think there's an advantage there in the e-locker. A lot of guys say that the air locker is stronger. It might be. I know that I've had my e-lockers on my Rubicon now for 100,000 miles, trouble-free, and that Jeep has not always been driven easy. So this video is getting long. I'm going to do another video on drivetrain, but I'm just trying to give you a little bit of insight from my perspective on what you need to do with the V8. So we got a lot more Jeeps coming up, and we'll see you soon.